Hi, it's Professor Adam. Let's talk about the relationships between different chemical equilibrium constants. What happens to Kc if chemical equations are balanced using different stoichiometric coefficients? In this reaction, A plus a half B2 giving AB has the following equilibrium constant labeled K1. But what if instead of the first equilibrium, equation 2, 2A plus B2 gives 2AB was used? This is just as correct as equation 1, but now K2, the equilibrium constant, has a different value. What is the relationship between these two? If the equilibrium constants are compared, K2 is equal to K1 squared. And thus, the relationship between balanced equations is that K value of the new equation is equal to the old equation to the power of the multiplication factor. Equally so, how does the rate of the forward reaction relate to the reverse reaction? Looking at the dissociation of acetic acid in water, the equilibrium constant expression is equal to 1.75 times 10 to the minus 5. The reverse reaction then has the following equilibrium constant value. This is the inverse of the value for the forward reaction, as the Kc value for the reverse reaction is simply the reciprocal of the forward reaction equilibrium constant. If a process occurs over multiple steps, the overall equilibrium constant value can be obtained as the product of the Kc values for the individual reactions, such as in the dissolution of limestone by acid. This reaction has the following component reactions, and their corresponding equilibrium constant expressions are these. This gives an overall reaction of calcium carbonate plus H+, going to aqueous calcium and hydrogen carbonate ions. The overall equilibrium constant is then the product of these individual reactions. So, in summary, if the same system is described by different stoichiometric coefficients, then the Kc of the new stoichiometry is equal to Kc of the original system to the power of the multiplication factor that describes the difference between the two sets of stoichiometric coefficients. If the Kc of one direction in the equilibrium is known, the Kc of the opposite direction is equal to 1 over Kc of the direction known. For a multi-step reaction, the overall Kc is the product of the equilibrium constants for each step. Let's check comprehension.